This is a battlefield where both armies have the same weapons capabilities, but one of them has AI and the other does not. Let's see how a battle between these two plays out. So let me show you how artificial intelligence is transforming war.
The examples that compel people the most are often the munition, the weapon system, the thing that does the killing, right? And this is the killer drone, the killer robot. But what I think is that often the key decisions in war are not the ones at the very end. They're not the ones that happen just before a bomb goes bang. And I think that's where AI is really affecting the battlefield the most.
Okay, so we've made these two hypothetical armies. Here on the battlefield, both of these armies are effectively trying to do the same thing. They're both trying to somehow get eyes into enemy territory, to find the enemy's most valuable military targets, to fix their exact location, to determine what weapons to use and how to properly target and deploy them, and then to actually fire on those targets, to engage so that it actually hits the target, and then finally to assess to see if it worked. This is called the kill chain, and it is how war is fought. But executing this kill chain is not straightforward. It's the job of commanders on both sides to make countless decisions, often with incomplete or unreliable information. And victory tends to favor those who can gather the best information and make accurate decisions the fastest. So let's see how both of these sides approach their kill chain, one with AI and one without.
Militaries will use what they call sensors to go find things. That could be anything that looks at the world.
Both sides have all sorts of sensors that are looking into their enemy's territory.
The classic example is an electro-optical sensor on a satellite, right? That's fancy words for a camera that is just looking at stuff.
They both have drones in the air, scanning for targets.
A reconnaissance team on the ground.
They've got radar, sensing what's flying through the air. The data from these sensors is being recorded and eventually is sent back to a central command center. This is where the decisions are made on what the army will do next, using all of this data from their sensors.
So someone has to be sifting through all of the satellite images.
And this is where we see the first big advantage for the side with AI, computer vision.
Object recognition has just exploded in how good it is. If you look back at the way that AI broke through and advanced around 2012, it was picking out images, in particular recognizing images of cats. And if you can recognize a cat, you can recognize a tank.
The AI command center is armed with computer vision software that is processing all of this incoming visual data and tagging it with what they think they're looking at and its precise location.
Now you have machines automatically looking over those images, picking out enemy planes, enemy formations, I'm pretty sure is a tank, with 90% probability. And I've worked this out on the drone itself, the exact coordinates it's at.
The other military that doesn't have AI is doing the same thing, but without computer vision algorithms.
There's a lot of friction in this process. You had humans poring over every single image.
They're slowly identifying their targets. A tank here, an airfield there, plotting them on a map, doing it manually. Oh, and by the way, this map only exists here in this command center. They haven't even started communicating all of these targets and intelligence to other command centers. Meanwhile, the computers over in this other command center are automatically adding all of their findings to a database that's in the cloud that other command centers have access to as well.
An AI-enabled army is fusing all kinds of data. Mobile phone records, data from ship tracking websites, aircraft tracking websites, consumer retail activity, who is buying products near this naval base or near that airfield that might indicate activity. So you're fusing these vast torrents of data, spitting out anomalies.
So their maps are filling up much quicker, filling up with potential targets and even context on each of these targets.
A commander who sees the targets then has to decide a lot of things. Are they going to hit them or not? Is it valuable enough? What am I going to use? Do I use a plane, an artillery battery, something else? These are all basically the bread and butter of any command decision.
But this is still just the beginning of the kill chain. These are hard decisions, but the AI-enabled commander has some help. A software platform has fused all of this data together and is starting to make predictions and inferences, giving recommendations to the commander, taking into account not only the target they're trying to hit, but also many other important factors.
I know that you have this many planes. I know that you have this much fuel on the airfield, this much ammunition. Here is the optimal way to destroy that target using these aircraft, coolant, fuel, oil, repairs, rest for the crew, food for the crew. These are all so fundamental. So a lot of the stuff that was being done in your headquarters by dozens of mid-level officers with pens, papers, spreadsheets can be done by software. The code can do it in like a tenth of the time, way more quickly.
So while the traditional army is still manually plotting potential targets, the AI army's commander is looking at a list generated by his software, a list of targets. The software is proposing that they could hit a group of tanks that they found near the front line. They could take out a bridge that serves as an important supply line. They could target an ammunition depot that the AI believes that most of the enemy's ammunition reserves are being held. The commander evaluates these recommendations from the software and decides to target the ammunition depot using some artillery cannons that the software has confirmed have recently been serviced and have plenty of ammunition for this operation. He taps a few buttons on a screen, and a mix of humans and software start preparing to engage. This all happened very quickly, and over on the other side, they're just starting to assemble an initial list of valuable targets. The AI-enabled commander now has time to think about other potential targets. Its software is recommending that he send a swarm of drones with explosives attached to them to destroy this fleet of enemy tanks. And here's where we see yet another massive advantage of AI. These drones are piloted by humans, but as they get closer and closer to their target, the enemy sends out jamming signals to interfere with the connection between the pilot and the drone.
Suddenly I'm not able to pilot my drone because there's all this radio noise overwhelming the signal.
The pilot can no longer control the drone.
What if the drone didn't need to have a pilot?
Thanks to recent advances in AI, this drone can start flying itself.
It is looking at the object, it's comparing it to a library of images stored on the platform, and it's saying, I know I am supposed to hit this thing. So it locks on to the target, and it says, I am going to just keep going. I can maneuver to that target in the final last 100 meters, 200 meters, 300 meters of flight. That's a real shift in the character of warfare when you have that precision guidance, not just on exquisite high-end systems, but on so many tiny little systems throughout the battlefield.
You can see where this is going. The AI-enabled army is able to pull off these attacks much quicker, with way more information, all enabled by algorithms that are crunching huge amounts of data. So even though these two armies have the same hardware, what matters more and more is what's inside. Let's go through a few examples. Like in Gaza, where the Israeli military uses data from tapped phones and people's locations to algorithmically choose targets to strike.
It's a kind of AI target system, generating huge numbers of targets per day of suspected Hamas militants.
According to 6 Israeli soldiers speaking to an Israeli publication, the IDF has based a lot of its airstrikes off of AI-generated lists, treating these target lists, in their words, quote, as if it were a human decision. Now, the IDF does dispute this characterization, but the point is, AI algorithms are already being used on the battlefield to choose targets. Then there's Ukraine.
Ukraine, above all, is going to be the key test bed, because that's where we're seeing some of the most advanced military AI play out on both sides, tested, experimented.
We are seeing more and more tech startups who are preparing for this new form of warfare, one that relies so much more on sensors and data and algorithms that can make sense of it all to make wartime decisions. The US military has been developing an AI system that can take a massive amount of aerial and satellite imagery and pick out potential enemy targets, sometimes more accurately than humans can. The UK has a similar program. And because data from sensors is such a huge part of this capability, you see more cloud computing companies like Amazon and Microsoft getting involved in defense. The holy grail for any military trying to get ahead on this is to aggregate all of the data from all of their many sensors into one integrated platform, one central command software that can help commanders make decisions. Okay, but wait, shouldn't we slow down and ask, yes, we can do this. This is something that technology allows us to do now, but is it ethical? Is it legal? Is it safe? Could it get out of control if we give more and more information and decision-making abilities to a computer? Will AI make war easier and quicker? Will taking humans out of the process make it less humane?
A lot of people who are against what they call killer robots will say a human must always retain control over the decision to use force. Do I kill them or not? I think that's the wrong way to think about it. The bit that will always be most controversial is the final lethal decision. You could argue the really consequential step was taken when you identified something as a target in the first place. Would we rather have a commander who is pressing a red button to approve a target that's offered to him by a computer, but is mashing the red button on loop, saying, yep, yep, yep? That doesn't seem like human control to me, even though from a technical perspective, yeah, they're signing off on each target, but they're doing so without any real engagement, moral or intellectual, with what they are doing.
Like any technology, it's not one way or the other. It comes down to how well we understand it and how we use it. Shawshank argues that what's most important isn't whether or not we give decision-making and autonomy to these machines, but whether or not the human who is in control and actually making the decisions based on what the machine is telling them understands the software, what it's good at and what it's not.
Whereas if you have a computer system that is offering a bank of targets, and the commander is scrutinizing those and knows the system, he knows what it's been trained on, and therefore he knows when it might work effectively and when it might not. And he knows when not to rely on it. He knows when to question it, when to mistrust its inputs. That seems to me much more like human control, even if he is ceding quite a lot of control in some circumstances, but holding it back in others. For me, that is the debate. It's way more complex than, hand over to the killer robots or not. It's when are you trusting the systems? What do you know about them? Have you interrogated them to understand what their weak spots are? That, to me, is really where the debate should be.
The reality is, there's no going back. No one's going to pump the brakes on integrating AI technology into warfare. No one's going to wait for the ethicists and the lawyers to decide if this is ethical or legal or safe. Geopolitics will force this forward. All we can hope for is wisdom and foresight from those making the decisions on how we use these systems so that we approach it humanely and responsibly.